first thing, we're going to hang our small angle approximations on. The reason why it's an approximation is we're hanging it on the idea that sin x and tan x, they look the same where it crosses through the origin. Like both of them are sloping upwards at a kind of 45-ish degree angle. They look about the same. And we find on our calculator that tan of 10 degrees is pretty close to sine of 10 degrees. And kind of as we get higher and higher, they get further and further apart. But when the angle is small, like when our pattern is restricted to a small angle, we find we can use sin x and tan x to be the same thing, which is really cool. And so this is what our triangle that we've been using to find out the distance from the central maxima to the point of interest on the screen. The L is the distance from the grating, or the double slit, the thing that's splitting the light, up to the screen. And that's the angle there, the angle to the point of interest. And so just looking at that triangle, we can see that tan theta is equal to x over L. And we know from our equation that we developed that n lambda is d sine theta. And so what's really useful is we can take this idea that sine theta and tan theta are more or less the same, and instead of writing sine theta, we can write d tan theta, and then we can be like, damn, it's not tan theta, it's just x over L, because we know from our definition from that triangle that tan theta is exactly x over L. And so we can rewrite this equation to use only when our pattern is restricted to a small area of the screen, that n lambda is dx upon L. This thing is like the devil. This is going to tempt you into sin. It's going to offer itself up to you as an easy solution to a complicated problem when you're sitting in the exam room in the hall at the end of the year, and you need to not allow yourself to be dragged into temptation by this. So this is okay to use when the angle is small. It's okay to use when we can legitimately say that sin x and tan x are so close together that it doesn't matter. What sort of situation is it that our pattern is restricted to a really small angle? Where do we get those small angle patterns? How are we creating those patterns?
With not so many slits, I guess you make.
Yeah,
See our laser and slits.
The red laser. So that's the red laser going through double slits. And just check out, I'm going to slide the red laser along, and the cool thing about these double slits is they're set up that they get closer and closer and closer together. So check out what happens to those maxima as we slide this along to make the slits close together and closer together. What's happening to the pattern as the slits get closer together?
Do they get longer?
Yeah. Because their spread is getting. What's happening to the angle between them?
Oh, getting longer.
What's happening to the angle between each maximum? It's getting bigger and bigger. So as the slits get closer and closer together, the angle we have to go out to make that path difference is bigger and bigger and bigger and bigger. And so with the double slit, when we had the double slit down the back of the classroom and our pattern was kind of that big, so from 10 metres away it was spread across a metre, yeah, we're comfy that a 1 metre spread over a 10 metre distance, that's way less than 10 degrees. And so we're comfy that we can use this, but don't be like that. They're often setting up questions in a way that's going to tempt you into using this as a really easy way of solving a problem rather than drawing the triangle, calculating the angle, and then using tan. Most of the time, we can't use it, so just be aware of it. It's like,
do you ever have to use that equation? Because you can just do it the long way. even if you can use that, right?
Yeah, the long way is always going to work. It's always going to work to use n lambdas d sine theta and then bang that theta into this triangle and use tan. The cheats way works when the angle is small.
Okay.
So we should just never use it.
Yeah, right.
Except for we've been lazy.
Like,
So use only when the angle is less than around about equal to 10 degrees, and that's going to happen when you've got a double slit and the slits aren't too close together. But it's important to know, because it is on your formula sheet, and so it's going to tempt you, it's going to be there inviting you to use it. And it's also important to know because they might ask you to justify, it would be a very legitimate question to ask you to justify when it is okay to use that question. And so having a knowledge, use that question, use that equation. So having a knowledge of, oh yeah, that equation is okay to use when it's acceptable to say that tan x and sine x are the same thing. That's what we've built that equation off, and that only happens kind of near the origin, because once we go up from the origin, tan's going way off up there, and sine's starting to flatten off at 1, whereas tan heads up to infinity. So yeah, they're very different values by the time you get to 90 degrees, but at about 0, they're about the same.
cool.